right, so now we're on the back, example 3. It says, given that a polynomial has a given root, find all the roots of the polynomial. So again, in case you forget what a root is, another name for a root is an x-intercept or a zero. They're all the same thing. They mean the same thing. X-intercept, zero, root. So they're telling me negative radical 3 is a root, and here's my polynomial. Well, we said that if you have a irrational root, then they come in pairs. So if negative radical 3 is a root, then we know positive radical 3 is also a root. And so in the next couple sections, we're going to be pulling everything that we've learned from section 2.2 and 2.3 and into 2.4 and then finally into 2.5. Well, everything will come together. So it's a lot. We're building on to look at polynomials in general. So if I know these two are roots, I can find the polynomial that gives me these roots by doing the x squared minus sum x plus product. And how that's going to help me, I'll explain that in a minute. So the sum of these two is 0, and the product, negative radical 3 times radical 3 is negative radical 9, which is negative 3. So the polynomial that has these two numbers as roots would be x squared, no middle term because the sum is 0, minus 3. So I know this polynomial, because these are roots, has to be a factor of this bigger polynomial. So if I know that this is a factor, I can divide that into this, and unfortunately I have to use long division because this is not a linear factor. It's not x minus 3 or x plus 3. I have to use long division, and then I'll take what I get from that. And remember, if this is a factor, my remainder will be 0. Once I get my quotient, I'll take that quotient and either use a quadratic formula or factor it to find the remaining zeros. And then you can always use your calculator to verify. So x squared minus 2. So I'm going to do x squared. If you want to put a 0 placeholder, you can. So the plus 0x minus 3. And then here I've got x to the 4th. I've got an x to the 3rd term. I have an x squared term. And my linear term, or my x to the 1st term, and then my constant. So I don't need any placeholders inside here. So again, x to the 4th divided by x squared is x squared. And then I take x squared and multiply by all of this. So x squared times x squared is x to the 4th. X squared times 0x is 0x to the 3rd. Again, see, these are like terms, so that's why we have to put a placeholder. And then x squared times a negative 3 is negative 3x squared. And then we're subtracting. X squared minus x to the 4th minus x to the 4th, that cancels. Negative 2x cubed minus 0x cubed is negative 2x cubed. 7x squared minus a negative 3x squared, that means this is going to become plus, so that'll be plus 10x squared. And then we bring down the next term. We have to have 3 terms because we have 3 terms here. And then I start over. Negative 2x to the 3rd divided by x squared is negative 2x. Then I take negative 2x and multiply by my divisor here, which would be negative 2x to the 3rd. Negative 2x times 0x is 0x squared. Negative 2x times negative 3 is positive 6x. And then I'm going to subtract. So negative 2x to the 3rd minus a negative, this would become plus, and those would cancel. 10x squared minus 0x squared would be 10x squared. And 6x minus 6x is 0x. And then I'm going to bring down my negative 30. 10x squared divided by x squared is 10. And then I multiply 10 by all of this out here. So 10x squared, 10x times 0x and 0x. 10x times negative 3 is negative 30. Subtract, those will cancel. 0x minus 0x cancels. Negative 30x minus a negative 30 becomes plus, so that gives me a remainder of 0. And we talked about that. Since this has to be a factor because these are roots, I will get a remainder of 0. So now I'm going to take this, x squared minus 2x plus 10 equals 0, and I'm going to see if it factors. Are there factors of 10 that add to 2? That's not going to factor, so I have to use the quadratic formula. So a is 1, b is negative 2, c is 10. So I have the opposite. So here's the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So if b is already negative, the opposite of that would be positive. Plus or minus. If I square negative 2, I get positive 4. Minus 4 times 1 times 10. All over 2 times 1 is 2. 2 plus or minus 4 minus 40. So 4 minus 40 is negative 36. All over 2. So 2 plus or minus the square root of negative 36 is 6i over 2. So 2 divided by 2 is 1. This divided by this is 3i. So these are my other two roots. So all the roots are negative radical 3, and 1 plus or minus 1 plus or minus 3i. So what this means graphically, if I go to graph this polynomial, I'll put this clear. So I'm graphing x to the 4th minus 2x to the 3rd plus 7x squared, 7x squared plus 6x minus 30. So we have 4 roots because we have x to the 4th. We have 4 roots. There's 2 here, 1 plus 3i and 1 minus 3i, and then we have negative radical 3 and positive radical 3. When I go to graph that, remember a root is where it crosses the x-axis. So I'm waiting for it to graph. And you can see it's only intersecting in 2 places. That's because these 2 over here, the 1 plus or minus 3i, are imaginary. That means they're not going to cross. We're not graphing in the imaginary coordinate plane. We're graphing in the real number system here. So that's why. And if I find those zeros, you can see they're between negative 2 and negative 1, and radical 3 is between those. Over here, my zeros are between 1 and 2, and radical 3 is between 1 and 2. It's like 1.7 something. So this is kind of validating what we see here as our answer. So this next one, they're telling me 2 minus I is a root. So that means 2 plus I is another one because it's a conjugate. So my sum, if I add these, 2 plus 2 is 4. Negative I plus I is 0, so my sum is 4. My product, so 2 minus I times 2 plus I. Remember, I only have to multiply first times first, so 2 times 2 is 4. Negative I times, and then last, negative I times positive I is negative I squared. So 4 minus I squared is negative 1, so it's 4 plus 1, so the product is 5. So the sum is 4 and the product is 5. So my equation with these roots, or my polynomial with these roots would be x squared minus 4x plus 5. So then I'm going to do long division. So I have x to the fourth minus 5x to the third minus 3x squared plus 43x minus 60. X to the fourth divided by x squared is x squared. Then I take what I wrote up here and multiply by everything in front. So x to the fourth minus 4x to the third plus 5x squared. And I'm going to subtract. X squared minus x to the fourth minus x to the fourth gone. Negative 5x to the third minus a negative. That means this is positive. That would be negative x to the third. Negative 3x minus this would be, make that this. So negative 8x squared. Bring down the 43x. Then I'll do negative x to the third divided by x squared is negative x. Negative x times all of this is negative x to the third plus 4x squared minus 5x. I'll subtract. So negative x to the third minus a negative x to the third becomes positive here. Those cancel. Negative x squared minus 4x squared is negative 12x squared. 43x minus a negative, which makes this positive, so that would be plus 48x. And I'll bring down my negative 60. Then I'll do negative 12x squared divided by x squared. That'd be negative 12. Multiply negative 12 by everything outside. Negative 12x squared plus 48x minus 60. Subtract. Negative 12x squared minus a negative, that means this is positive, those cancel. 48x minus 48x, 0. Negative 60 minus a negative, what makes that positive, is 0. So my remainder is 0, which we said that has to happen because we know this is a factor of the larger polynomial because these are roots. So then I'm left with x squared up here, that's what's coming down here, minus x minus 12 equals 0. And so actually this factors, which I love it when it factors. I don't like the quadratic formula. So x factors of 12 that subtract to give you 1, 4, and 3. My signs have to be a negative 4 and a positive 3. Set them equal to 0. So x equals 4 and x equals negative 3. So my final answer, what are all the roots? So all the roots are, back at the top, 2 minus I, 2 plus I, 4, and negative 3. So if I go and put this in my graphing calculator, this original polynomial, I will see that there is a x-intercept or a root or a 0 at 4 and negative 3, and then this will not show up. So we can just go ahead and check. We clear that. So I've got x to the fourth minus 5, x to the third minus 3x squared plus 43x minus 60. And I'm going to graph. Remember, the ones that we should see is negative 3, which right is there, and positive 4. So that's 2, 4. Have a great day.